What is up, everyone? Welcome to this video, and today we're going to be covering toSum, which is a very common and fairly easy Leetcode question. So what the question is basically asking is, let's say you have an array of integers, and what they want you to do is return indices of two numbers or elements in this array that add up to a specific number. And you're assuming that there's only one solution and you cannot use the same element twice. So if you're still confused, let's look at the example. So let's say you're given this integer array, nums, which has 2, 7, 11, 15 as the elements. And the target is actually 9. So what they're saying is, find any two elements in here, right, that when you add them together, they give you the target, which is 9. So it's fairly easy to see that 2 and 7 add up to give you 9, right? So what they want you to do is actually return an integer array given the indices of the two elements. So the index of 2 is 0. The index of 7 is 1. So we're going to actually return an integer array of the indices, so 0 and 1, right? So how do you actually do this? Well, let's first consider a brute force approach, because it's very good to actually consider what's the most obvious way to actually do or solve a problem, and then you can actually make it more effective and more efficient, right? So the brute force way is pretty simple, right? You have a loop. You basically loop through this entire array, and then let's say my first iteration, I'm at 2, right? I'm basically going to check all the elements on the right and check if any of them, when I add them to 2, give me 9, right? And I'm going to repeat that, so I'm going to go on to the next iteration. So I'm going to go to 7. Are any of the elements on the right of 7, when I add them individually to 7, do any of them give me 9? If so, we're done. If not, continue, right? So let's actually implement this. So we would make a for loop. So guys, remember, this is not the most efficient way. I'm just going to kind of try not to spend too much time on this because this is not the optimal solution. I'm just kind of introducing you guys how to kind of approach these type of Leetcode questions. And so this is what we do. Oops. Right? And then now we have a loop, right? That's great. We have a loop. And then what we're going to have to do is have another loop, right? Because at each iteration, so let's say the first iteration, I'm going to have to loop through all the elements on the right and check if any of them add up to 9 when you add them with the element here, right? So another loop would be, let's say j, and j is initially what? J is initially the value of I plus 1, because remember, so let's say we start off at 2. I'm going to compare in all the elements on the right and check if any of them, when you add them with 2, give you 9. So I'm going to actually start off by I plus 1. So I'm going to start off at 7 in this case. So I plus 1, right? And then I'm going to be checking if j is less than nums.length, making sure that it is. And then inside the loop, all I'm going to be doing is checking, right? So I'm going to check if nums I, right? So nums I plus nums j gives me the target, right? What this is saying is basically, let's say we start off at 2, and I'm saying, okay, I 0, right? So I'm at index 0, which has 2, and I'm actually going to start off by j, which is I plus 1. So at index 1, and I'm going to check, is the number at index j and the number at index I, do they add up to make target, which is 9? Well, yes, they do. In this case, the first iteration gave us the answer, but in other cases, it might not work, so it's going to have to keep looping and iterating and checking. So we're going to actually return an integer array, and the elements are going to be the indices, because that's what the question asked for, right? Not the elements, the indices. So the index of 2 is actually I. The index at 7 is actually j, right? So now we're done. That's it. This is actually going to throw an error just because, you have the return statement inside the if statement. So in the case that it actually doesn't go through this, it's going to throw an error. But it will definitely go through this because they gave us they said you can assume that there is exactly one solution. So how you can actually, overcome this, you can just throw an exception and it'll basically catch it, right? So no solution, right? So in the case that somebody adds a test case that doesn't have solution, it'll basically throw this exception and the program will catch it, right? So let's actually try this and see what happens. As you can see, it worked, but is this the most optimal solution? No, because realistically this is running in time complexity of O of n squared, which is not great, right? So the reason is because, think about it, you're looping through this array, and at each iteration you're again looping through all the numbers on the right, and that's not great. There has to be a more effective way of doing this, right? So let's actually just scrap this. We'll keep the exception just because, you know, we're going to run through the same issue if you don't. And so how we can actually do this is we can use a hash map. A hash map is great because a hash map has constant time operations. So if you want to add, remove, insert, search for a specific element, you can do it in O of 1, constant time. So let's actually create a hash map first of all. So the hash map is going to have a key type, a data type of integer, and a value type of integer as well. I'm going to call it hash map equals new hash map. So if you're not familiar with hash map, it basically is a structure that has elements with key value pairs, right? I'm assuming you have an understanding of hash maps. If you don't, I'd recommend looking into those more in detail. But the idea is that you have key value pair elements and the operations are constant time, right? So what am I exactly going to do with this hash map, right? Okay, cool, there's constant operation times, but like how am I going to solve the problem? Well, let's imagine that we can actually loop through this array, right? But only once. We're going to loop through, and then at each iteration we're going to actually add the value of the element as a key and the index of this element as the value of this hash map element. So I'm going to have another for loop. So then another for loop is going to have same thing, right? I has to be less than nums.length and then I plus plus. Great. And then at each iteration, like I said, we're going to actually add that to the hash map. So I'm going to say hash map dot put, right? This is how you add an element, or you put an element in the hash map. And so this element has, again, a key value, right? It's a key and a value. So the key is actually going to be the current value of the element. So let's say we start this loop, right? Index is I, so we're actually at 2, right? So the value is 2. We're actually going to put the value as the key. So 2 would be the case here, right? So we're going to put in nums I, which is 2 for the first case, right? First iteration. And then the value of this key value pair is actually going to be the index. So it's going to be I. So essentially what we did here is we said, okay, I actually added 2 as the key, right? And then I added the index of 2, which is 0, as the value of this hash map element. Okay, great. So we're done, right? We basically have a hash map with a key value pair, the key being the element value and the value being the index, right? So now what we can do with this is we can actually loop through, right? But outside, we're not going to have an inner loop. We're looping through outside the other loop. And what we're doing is we're actually checking, right? It's going to be the same thing. We're looping through the entire length of the array, and we're going to be checking if there's a complement in the hash map. So a complement is basically the number that you need to add up to make the target, right? So for instance, let's first define it, right? Int complement. Basically, what is the complement of 2? The complement of 2 is 7 because the target 9, right? When you subtract the value of 2, you get the complement, which is 7, because 7 plus 2 gives you 9, right? So the complement, how you can get it is you can say complement is equal to target, right? Minus what? Minus the value, right? So minus the current value at index I. So when we first run this loop, the first iteration is going to be target being 9 minus the element at index I, which is 2. So 9 minus 2 gives you a complement of 7. Then what we're going to do is we're going to make use of the hash map that we actually created here, and we're going to say, okay, does the hash map actually contain the complement? Does it contain the key being the complement? Does it? So does the hash map that we've defined here and actually added all these values, we've added 2 as 2 and as a key, and then we added 0 as the value of that key value pair, 7 as a key, 1 as the value of that key value pair. Does it contain an element with a key 7? Yes, because we did that here, right? So since it contains the complement, i.e. it contains 7, we know that we've found, or we have another element in this array that actually complements, and actually when you add it up to the other value, it gives you the target, right? So what we need to do now is actually return the integer array, and the values are going to be what? The values are going to be the index of the first element, which is I, right? And the index of the second element. And how we can get that is we can get it through the key, right? We can say hashmap dot get elements, right? So get complement. So it's going to basically, okay, say go to the hash map and find me the value of the element with a key of complement, which in this case would be 7. So it's going to give me the index, which is 1, because that's the value we stored here initially, right? And so now we're done, right? We basically returned an integer array with the indices, and it should work. So let's try this out. As you can see, it worked, and this is definitely much faster because it's running in O of n, right? Technically there's 2 for loops, but if you do 2 times n, it's O of n, so this is much faster. But there's still something you can do to make this better. Why do we have 2 for loops? Why can we not do the same logic here in this for loop? Let's actually try this. I'm going to copy paste this, delete this, and let's think about this. So we have a for loop that's actually just putting elements, and they're sort of putting keys and values in the hash map. But why can we not check at the same time to see if there's a complement? So I'm going to copy this code here, and let's actually run through this. So what I'm saying is I'm going to run through this entire array, right? I'm running through this entire array, and I'm saying, okay, complement is equal to target minus number I, right? So basically it's going to be 9 minus 2, right? So 7. And I'm going to say, does the hash map contain 7, right? If it does, return and blah, 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 right? But in this case, it doesn't, right? Because we just started. We haven't actually added the hash map yet, right? That's fine. What's going to happen is we're going to put, since we're not going to go through this if statement, we're going to actually put the key being 2 and the index being 0, and then we're going to go to the next iteration. We're going to say, okay, great. The complement of target, complement is target, which is 9, minus the number at the current index I, which will be 7, because again, we went to the next iteration. So 9 minus 7 has a, so the complement is 2, right? The complement of 7 is 2 to make it add up to 9, right? So now I'm going to say, hey, does the hash map actually have element with a key of 2? Well, yeah, we actually just added it in the last iteration. We just added an element with a key of value, with a key of 2, and with the value is actually the index. So index being 0 because 2 is at index 0. So great, we actually go through this if statement, and now same thing. We actually return an integer array with I being the index of the element, and then the other element's index, right, which we get from the hash map, right? So in this way, we basically did the same thing. We just, instead of having 2 for loops, we kind of put the same logic and the same check inside the same for loop. So it checks while it puts the hash map, right? So let's actually run this and see what we get, and this should work. And there you go, it worked. And this is the most optimal solution that you should be using. It's the cleanest and the easiest to understand and the fastest way, right? So thanks for watching, guys. Make sure to like and subscribe so you get a notification when we release the next video and the next Leetcode question. And if you have any Leetcode questions that you really want me to actually go over, make sure to comment it down below so I can actually get through that and help you guys further understand how to solve these questions. Thanks for watching, guys.